this is Mary G, and I'll show you how to determine if a sequence is an arithmetic or a geometry. But before that, we have to know what is arithmetic and geometric first. An arithmetic sequence is a sequence of numbers whose difference between consecutive terms are the same, while geometric sequence is a sequence of numbers with a common ratio. Let's have our first example, the sequence 8, 4, 2, 1, 1/2, and so on. First, let's check if this sequence is a geometric. In order for this sequence to be geometric, it has to have a common ratio. And to get common ratio, we need to take a term and divide it by the term that comes before it. So let's take a look at our first two terms in the sequence, and that is 8 and 4. To find the ratio of these terms, we need to take 4 and divide it by the term before it, which is 8. When we perform division, we get 1/2. So we are proposing that our common ratio is 1/2. To make sure that a sequence has a common ratio, we need to get the same value of ratio in the next set of consecutive terms. So let's take a look in the next set of consecutive terms. We have 4 and 2. We find the ratio by dividing 2 by the term before it, and that is 4. And we get 1/2. So our second ratio is 1/2. Now, we have the same value of ratio. In order to get from 8 to 4, we have to multiply by 1/2. And to get from 4 to 2, we need also to multiply 1/2. But does this pattern multiplying by 1/2 take to the next term continue? Well, we need to check the rest of the term in the sequence to make sure they follow this pattern. If they do, we have a common ratio, and that means our sequence is geometric. So let's look. Here, if we take 2 and multiply it by 1/2, we get 1. And if we take 1 and multiply it by 1/2, we get 1/2. This means that our sequence holds this pattern, and by taking a term and multiply it by 1/2 in order to get the next term in the sequence. That means that we have a common ratio of 1/2. And that also means that this sequence is geometric. Let's have our example number 2, the sequence 1, 4, 7, 10, 13, and so on. First, let's see if it is geometric. In order for this sequence to be geometric, we have to have a common ratio. And to get a common ratio, we need to take a term and divide it by the term that comes before it. So let's take a look at our first two terms in the sequence, and that is 1 and 4. To find the ratio of these two terms, we need to take 4 and divide it by the term that comes before it, and that is 1. And the answer is 4. So now we are proposing that our common ratio is 4. In order for this sequence to have a common ratio, we need to get the same value for r whenever we perform similar division in the next consecutive term in the sequence. So let's take a look in the next set of consecutive term, and that is 4 and 7. We find ratio by taking 7 and divide it by the term that comes before it, and that is 4. And our answer is 7 over 4. So now we have our second ratio, and it is 7 over 4. Now let's see. Is 4 equal to 7 over 4? Of course it's not, right? So these two ratios is definitely not the same. And since we do not have the same value of r, that means that this sequence is not geometric. But is it arithmetic? Well, let's see. In order for the sequence to be arithmetic, it has to have a common difference. So, we need to check if our sequence has common difference. Let's start with the first two terms, which is 1 and 4. To find the difference of these two terms, we take 4 and subtract the term that comes before it, which is 1. So it will be 4 minus 1, and the answer is 3. So we are now proposing that the common difference is 3. But we need to check the other consecutive term. So here we have 4 and 7. We find the difference by taking 7 and subtract by the term that comes before it, which is 4. So the difference is 3. Now we get the same difference. We have common difference, which is 3, and that means that to go from 1 to 4, we need to add 3. And to go from 4 to 7, we need to add 3 also. If this pattern continues to the entire sequence, that means we have common difference, and the sequence is arithmetic. That means in our next step, we need to check the rest of the term in the sequence if it follows the same pattern. Well, here we have 7, and we need to get 7 to 10. If we add 3 to 7, we get 10. And the next is if we add 3 to 10, we get 13. We have the same pattern, adding 3 each time we want to get the next term in the sequence. Since we have the same number we are adding each time, that means we do indeed have a common difference. And since we have common difference, that means this sequence is arithmetic. Hey, that's all for today. I hope you learned from it.